All right, thank you everyone for joining us once again for our webinar series. We are continuing with our webinar series, which is part of the annual celebration of Cybersecurity Awareness Month, an internationally recognized campaign held each year to educate the public on being vigilant about cybersecurity. Today's topic is combating adversarial AI, and our speaker is Sulakshan. Sulakshan is an STSM and architect of security analytics in the IBM Security Systems division. He was known for the work in Watson for cybersecurity, where he was the architect and took the concept to the product offering. He works on development of AI and ML-enabled security analytics platform deployable in multi-cloud environments, specializing in analytics. He worked in the IBM Security CTO's office, specializing in network security, AI, fraud detection, cloud security, and analytics. He is a lab advocate for key customers and an avid technical evangelist. Sulakshan holds a master's degree in computer science from the New Jersey Institute of Technology. Sulakshan, you have the floor, please.
Thank you very much, and good afternoon. Sorry for the confusion earlier. I was penned in for 12 p.m. Eastern time, and that's where I live. And I suppose the original webinar session was to happen at 12 p.m., but thank you for rejoining. So thank you for that intro too. And we will begin our webinar in a bit. So I basically laid out the talk in 3 phases. The first phase is generally going to talk about how we use AI in cybersecurity, then introduced a few examples of how adversaries are using AI to attack and beat the defenses of the cybersecurity. The last phase of the talk was basically going to go over certain technologies that we use today, including open sources, that can be used in defending against adversarial AI. So that's how I laid it out. So we'll begin with a few examples of, the AI that's being used in cybersecurity landscape, right? Pretty much everyone claims that there is a piece of AI in their software that they use in cybersecurity today. These include SIMs, this include identity and access systems, these includes some sort of data protection systems as well. And it's AI and machine learning, these are synonymous with innovation. So it's not too surprising that people are wanting to use AI and claim that as a key differentiator in their product offerings as well. It's ubiquitous. Use of machine learning models are ubiquitous. Data science jobs have gone up. And pretty much every security analyst is playing with the Jupyter notebooks with machine learning models and emulating a data scientist, right? Which they are not. And so if you look at the landscape itself, right? What do we really mean by use of AI in cybersecurity? So for the most part, what you have heard is predictive analytics. This is where people are looking at a lot of data and modeling the behavior based on what they see. And they use that model to identify any anomalous behavior, any deviations, any outliers, right? That's what predictive analytics is. A good example of that is a user behavior analytics product that we use in IBM. This is where we are modeling user behavior over a period of time and applying that the current behavior to identify any deviations there. We also use predictive analytics in identity and access systems. If somebody logs in from a different geographical endpoint or certain attributes of access have changed, then that's checked against the model that was trained with the previous behavior to identify, to do some sort of access certification. So what happens is it would throw an OTP if there is a deviation from the model, and you would have to use that multi-factor authentication to get through the identity access systems. We even use it for code analysis. Most people use app scan to scan vulnerabilities and stuff in their code. It's one of the surprising areas where AI is used, right? So AppScan actually uses machine learning models to reduce false positives. So this is all examples of predictive analytics. And whenever anybody says they have a piece of AI running and they have machine learning model, it's usually predictive analytics, where a model is being used to classify and identify anomalous behavior. The next category of AI, which is less popular and less used, is intelligent consolidation. This is where NLP comes into picture. This is where we are feeding a lot of data into a system and are using those systems to reason and answer certain things. Chatbots is a very vague example of that, but more powerful examples exist where if you so our Watson for cybersecurity in IBM, right? If you throw certain observables at it, it'll basically say that, oh, by the way, I've seen this observable in this malware campaign. And it's making that inference based on certain data ingested, based on blogs or security, dictionaries and stuff like that, that's being fed into and trained that NLP model in for cybersecurity. So that intelligence consolidation and using natural language to reason and assist in certain activities is also an important thing. Not many players exist in that space, and again, you would see that getting popular because with more regulatory compliance requirements, right, it becomes easier to consolidate those requirements as NLP data into your cybersecurity systems and use that for auditing. People have used chatbots and trusted advisors. This is where they're using that predictive analytics and consolidated intelligence to assist a security analyst, for example, right? Or H&R Block uses to assist tax filing, right? But let's scope ourselves to the cybersecurity area. So this is where security analysts are using trusted advisors to identify what's happening on their premise and connecting that with the larger security intelligence pool to identify attacks and respond to them. So all of this will culminate in some sort of robotic process automation, right? So you eventually see bots that are much sophisticated, which have machine learning embedded in it, which has optical character recognition embedded in it, being used to automate some of the tasks that security analysts are doing. With all of this, we are using AI to provide defenses. So are the attackers. They're using AI to power their attacks. They're using AI to bypass certain defenses that we built and counter the AI defenses that we have built. So there's need for AI robustness, right? So whatever we do, whatever machine learning models we build, we have to make sure that it's protected against adversarial AI as well. So now to the interesting area of how AI is used by the attackers to defeat the cybersecurity. This is the adversarial AI. So why are we talking about it? Why is this interesting? If this is a problem, right? Absolutely, right? AI is ubiquitous, just like developers, open source, and other communities are using AI to build their applications. Attackers have access to the same set of technologies to build their cybersecurity attacks as well. So back when I graduated, like 2 decades ago, I was taught to solve a problem by using procedural programming or databases. Now, pretty much everyone who's graduating out of school is coming out with the AI skills, and data scientist is the most popular job that's sought after, right? So if you give them a problem, they would turn that around and say, I'm going to use this classifier, I'm going to use this clustering, and solve that problem for you. So it's not uncommon for attackers to use AI as well. If you want to study use of AI by AI attackers, you can look at it as 3 categories. The first one is the AI powered attacks. The second one is AI attacking AI, which is AI versus AI. The last one is the theft of AI to kind of circumvent the defenses that we built. So what are the examples of AI powered attacks, right? One of the first thing that comes to my mind, a simpler one, is the X-Evil, which is this open source technology that's out there that you can use to bypass CAPTCHAs, and most of you have entered CAPTCHAs, right? While accessing any systems, correct? So this is where the the information security system is trying to make sure that there's a real human behind the computer, not a bot trying to access the system, right? It tries to ascertain that by throwing a picture at you, by throwing a sequence of numbers, sequence of characters that you need to enter to make sure that you're human. So the XEvil comes out with this model, AI model, that'll help you bypass the CAPTCHAs. So that's one good example that's being used quite often, right? And then there are other AI-powered attacks. For example, we all know about password cracking, right? So we use brute force. We've heard about brute force technologies where people can try this a million times and eventually get to the password, or probably get to your Facebook, get to your Twitter accounts, get to your other social media presence and identify personal information that can be used to derive at your password or attack you personally for that matter. But that's pretty intense, and that involves a lot of time and effort. But with AI, you could do it very efficiently, and you can do it at scale. Again, what we are talking about AI-powered attacks is they're generally there to do evasion. So you could probably categorize some of those AI-powered attacks as evasion attacks and automation attacks, right? And let's talk about attacking the AI part. As I told you in the few examples in the previous slide, we are using AI pretty much everywhere, right? Identity access systems, SIMs, or incident response. And attackers are using AI to attack those AI-based systems as well, because there's no human involved. It's the AI trying to make those decisions and operations. A good example of that is poisoning of chatbot, right? So Microsoft put this chatbot online a few years ago, and within a day, within 24 hours, they have to take it down, just because somebody has trained it to use anti-Semitic language and use abusive words. So the chatbot was throwing out all bad words, right? It doesn't take even our own IBM bots, and it doesn't take much to feed it in an Urban Dictionary and make it polymath, right? It's what you train. These chatbots would behave exactly the same. So that's called the poisoning of the attacks, and you would see a similar pattern when you talk about machine learning models as well. The other example is this is where autonomous driving comes into picture, right? We all know that Tesla and other car makers are using autonomous driving where an object is identified, and that's all. It's called visual AI, basically, right? So imagine an attacker. I'll show you the real examples, right? These are all in the news actually, and this slide was probably older. This is where attackers are using to evade or trying to cheat the system by using some sort of evasion techniques, right? If you see the picture at the bottom of that second column, right? So we have a machine learning model that's identifying a person on the right with the psychedelical glasses as a female. So it's classifying that picture as a female versus a male, and it's not that hard actually to bypass or circumvent the machine learning models to do the same. It can be dangerous sometimes, right? When somebody is using an autonomous vehicle, imagine you're tricking the autonomous vehicle to use a stop sign by putting some sort of sticker on it or some sort of figuring it and making it a speed limit sign, right? It could run into serious problems as well. And this has happened. This is true, right? People are using that to defeat AI systems. The last one, of course, is the theft of AI. And this is where when we expose our APIs, people learn how the classification is being done. This is basically discovery of how AI is being used to do classification, or how AI is being used to do some sort of decision making. They are stealing data by understanding that model. A good example of that is at the bottom of that you would see a picture that's fuzzied around quite a bit, right, to match another person. So imagine somebody is using facial recognition. So you would experiment with that facial recognition system by throwing like thousands of photographs, but just coming up with a fuzzy logic that would create certain patterns in pictures that would basically make the system believe that it is the right person, or it would recognize the person as a different person, right? So you would just experiment. It's sort of a brute force, but it's AI, so you can do it pretty fastly by creating like lots of pictures. OpenAI is another good example, right? So you can create lots of pictures and see if that will make the system that can trick the system. So these are interesting areas where AI is being used by the attacker. So again, so think about it as evasive techniques that these attackers are using. They're pervasive and they're adapting to whatever defenses that we put, right? So AI-based hacking uh, bots have learned how to break into web applications with SQL injection and neural network and neural and reinforcement learning. So there are techniques, and it's getting pretty advanced as well. So these have been talked about in DEF CONs and black hats all the time. Here is an example of deep locker, right? So this is our own IBM research that has produced a malware that uses AI to attack people. So it created a little bit of malware that basically observes you and uses certain evading techniques, right? So it certain uses your keystroke behavior, it uses your facial recognition, it uses your behavioral patterns, it observes it, and it only detonates when it's when you're at the most vulnerable time, right? So things like that. So go read about the deep locker. You would understand how AI was used to power an attack on a simple ransomware attack that would detonate based on observing certain things. So when I'm saying observing certain things, right, it has the visual recognition capability. Uh, it has an understanding of how keystrokes are being used. It can learn from that behavior and can evade the defenses that you would otherwise be counting on. Here are the real world examples, and that's what I really wanted to talk about, right? Like, so we have, remember I talked about this stop sign. So hackers have steered Tesla onto oncoming traffic by placing 3 small stickers on the road. And you can see a lot of examples. These are all examples trying to bypass security systems that we have, causing loss of control for autonomous vehicle, leading to serious injuries. And evasion of classification in antivirus product would result in ransomware installs that would encrypt your computer. And then it would also result in leaking of sensitive private information, based on certain inferences that the AI-powered attacks can do. So that's the background of the general use of AI by the bad guys or the attackers by using evasion techniques and the other techniques, theft and stuff like that, to perform cybersecurity attacks. So why is this a top priority, right? And we have regulations driving that. We have regulations that are saying that AI needs to be trusted. So we have to do everything to make sure your AI is not biased, the training is being done properly, and we have to protect the brands that use AI in their day-to-day operations. So general focus on social justice that has happened over last half a decade or so. So these are all the regulations and the movements are driving people to worry about how they deploy AI. They want to make sure the AI that's deployed is in compliance with the regulations. Is robust. It's not subject to bias or anything like that. So we've come up at IBM. We've done. We believe that protecting would actually mean essentially hardening the models. So we do it by 3 ways, right? So we have 3 elements in protecting machine learning models against the adversaries. So you have to hardening the model, measuring the robustness, and detecting adversarial input at the test time. So how do you measure model robustness? Firstly, the robustness of a given, say, a deep neural network can be assessed a straightforward way by recording the loss of accuracy on adversarial inputs. So there are other approaches which measure how an internal representation and the output of DNN vary with small changes that applied to the inputs, right? That's how you measure the model robustness and harden the models. How do you harden the models? So given a neural network, it can be hardened or made robust against adversarial input um, by augmenting the training data with adversarial examples, or changing the DNN architecture to prevent adversarial signals from propagating through the internal representation layers. And finally, the runtime detection methods can be applied to flag any inputs that an adversary might have tampered with. Those methods typically try to exploit abnormal activations in the internal representations of the neural networks caused by the adversarial inputs. So generally speaking, right, there are other types of attacks we talked about, right? So there's a poisoning attack. How can you tell when the training data has been poisoned? Can you repair a model that has been poisoned? Misclassification of inputs is usually the root cause of some of these things, right? An adversary aims to shift the decision boundary of a model to make sure that a specific input is misclassified into a different target class, right? And we have seen this, a stop sign not being recognized as a stop sign, but using making it recognized as a speed limit sign is a dangerous thing. Your model performance can be reduced. This is where the adversary's objective is to limit system's usefulness. Here is where adversary attempts to reduce the overall accuracy of the model by resulting in general misclassification. Poisoning threats are particularly relevant when training data is obtained from untrusted sources, such as CrowdStrike. I mean, to begin with, to deploy any AI, we have to train and we are scouting for those models, scouting for that data, do the transformations. So data is the fuel for implementing any of these AI systems, right? The source of it must be trusted. The risk increases when the model requires frequent retraining and customization, right? And the ability to detect when models have been poisoned or tampered with is vital when they're trained by untrusted untrusted third-party data that we're getting. I mean, I can tell you that in our own Watson for Cyber, we crawl a lot of websites and URLs to gather the security intelligence on latest malware campaigns. And we train our Watson for Cybersecurity model using that NLP data, right? So imagine if some of those sources are contaminated or polluted or some sort of poisoned, right? Then our resulting output would also be impacted. So we have to have something built into the pipeline of the training where it's detecting detecting these poisoned attacks. So what we did at IBM is to help people who are developing a adversarial AI, defense against adversarial AI, of course, right? We have open sourced this technology called ART, or Adversarial Robustness Toolkit. There are plenty of tutorials on how to use it, and it provides an implementation for methods for defending, attacking and defending classifiers, right? And this allows rapid crafting of analysis of attacks and defense methods. So it has an adversarial model that you can use to train and test your data as well. I'll show you some examples and you'll get a good hold of it. So it can be used by both blue teams and red teams, right? So blue teams are trying to do detection of poisoning, detection of evasion, and trying to verify that the model is working correctly. On the other hand, your red team is evaluating by poisoning the training data, right? And this is where you're intentionally introducing some adversarial input into training data and trying to evaluate the model outcome or model output based on the original test data. So attackers can, so the red teams can infer the outcome of these machine learning models by using that training data that's been poisoned. And you can, the red teams have the tooling within the robustness toolkit to kind of figure out if they're subject to evasion it'll help in evaluation of effectiveness of these machine learning models. So they have good number of defenses built into the toolkit. They have robustness metrics. They have good examples, 30 Jupyter notebooks covering these attacks and defenses. I strongly recommend people to go out and try out. And there's a detailed webinar just focused on the adversarial robustness and toolkit. And we also have bias detection and explainability to make sure that the outcome of these machine learning models are measured and explained in a way that we can assess the accuracy of the model classification. Here is a good example, right? So this is how you use it. So you can see that there is art attacks. There's art classifier, art metrics. What you do is you would load your own model, and then you would perform an attack using the classifier and measure the loss of efficiency using the metric calculations that come with the tooling, right? You can use actually adversarial data. So it's not listed in the examples, but there are other examples where you can use the art dot attack and then train the data with the adversarial input, see how the classification varies based on input given. These are all the tools that are in open source, and I'm sure Google has certain things out there as well. But art is one of those things that we internally at IBM embrace to kind of make sure that our machine learning models are doing a great job as well, defending against the adversarial attacks. There's nothing that beats the countermeasures that we can deploy within the DevOps pipelines, actually. So ground truth protection is essential here. This is where we are making sure the training data is protected, and the secrecy is protected. We are making sure that the data that we're using for training is coming from trusted resources. Then we build the robustness model by either using the techniques and algorithms I listed before, and they need to be resilient just by construction, right? And then when you deploy these deploy the AI, the operational security comes into picture. This is where we detect and eliminate the adversarial input in production.